Hey guys, now we're going to be solving exponential equations using the property of equality for exponential equations. That property is stated above. So two powers with the same positive base, b, where b does not equal 0, are equal if and only if their exponents are equal. So we can use this property to help us solve equations. So if you look at this first example, 2 to the x is equal to 2 to the 5th. Since the bases are equal, we can set the exponents equal. So let's look at example 1a. We see that the bases are both 3. So we can set the exponents equal to each other. And we can solve for x. So we have an equation then of x plus 1 is equal to 5. And of course, I think the answer is obvious here. You would subtract 1 from each side, and x is equal to 4. For this first example, you technically don't even need to write an equation because I think it's easy to understand and see that if you have 3 to the x plus 1 and you know that the other side is 5, this number can only be a 4. But as the problems get harder, it won't be so obvious. So let's look at the next example. We have 6 is equal to 6 to the 2x minus 3. So this first 6 looks like it has no exponent, but technically it's 6 to the 1 is equal to 6 to the 2x minus 3. So since the bases are both 6, we can set the bases equal to each other. That's also called equating the exponents. So this word equate really just means set them equal. Okay, so you have 1 is equal to 2x minus 3, and then you would solve that two-step equation to figure out what x is. So the first step you should do is add 3 to both sides. And that will give you a 4 on the left-hand side. 4 is equal to 2x. Then divide by 2. And then once you divide by 2, you get an answer of 2 for x. For example C, you can also notice that the bases are the same. So the bases are the same. We can equate the exponents. And that simply means just setting them equal to each other. So you're going to set 3x equal to 2x minus 3. And we want to get the x's all on one side of the equation. So if you subtract the 2x, we will end up with a positive coefficient on the left side. So we will have x is equal to negative 3, and then you're done. So the reason I didn't subtract the 3x over, because if you do that, you end up with 0 is equal to negative x minus 3, and we kind of want to avoid having a negative x if we can. So in this case, it would have been better to subtract the 2x from each side. So now we're going to get into some examples where the bases are not the same. So if you look here at this first one, letter A, 5 to the x is equal to 125. So this one may be a little bit obvious, especially if you know your perfect squares, if you know your cube roots, etc. So this answer might be obvious, but to follow the property, we would need both terms on either side of the equal sign to have the same base. So right now what we have is 5 to the x, and then the base on the other side is 125, and they don't match. So if we're going to follow the property, we're going to need them to match. Okay, so if I wanted to rewrite 125 with a base of 5, I'd have to think about 5 to the what power is going to give me 125. So in this case, I could say that 5 to the third power is 125, and then you can equate your exponents. So x would equal 3 for this one. For letter B, notice our base is 4 and 2. So if we want to use the property, we have to make sure the bases are the same. So we're going to rewrite 4 to the x with a base of 2. So that means 2 squared is 4, and then that would be 4 to the x, and that would be equal to 2 to the x minus 3. Now we're going to apply one of our properties of exponents, which is going to be the power of a power property. Which means we're going to multiply the exponents. So on the term on the left, you would have 2, and then you would multiply the 2 times the x, which is just 2x. Sorry, that's my phone. And then now we have 2 bases with a 2, and now we can equate the exponents. To solve for x. Okay, so then we're going to do 2x is equal to x minus 3. Then you could subtract x from each side. So subtract it from the left and the right, and you get x is equal to negative 3 for your answer for B. Okay, for the next example, our bases are 9 and 27. So we have to make sure they're the same. So I know that 9 squared is 81, and we want to think of numbers that both 9 and 27 have in common. So hopefully you're thinking of the number 3, and we can rewrite 9 and 27 with a base of 3. So I know that 3 squared is 9, and you put the exponent on the outside, and there's actually a mistake in your notes right here. This should be 27 to the x, by the way. So make sure you fix that on the exponent on the 27. And then 27 can be rewritten as 3 cubed to the x. So now both of our terms on either side of the equal sign have a base of 3. So we now apply the power of power property. Which means we're going to multiply the exponents. So when you do this, you're going to end up having to apply the distributive property on the left-hand side, because you're doing 2 times the sum of x and 2. So now we're going to equate the exponents, which means we're setting them equal to each other, and we can do the distributive property within that step. So 2 times x is 2x, plus 2 times 2 is 4, and that's equal to 3x. So then we're going to subtract the 2x from each side. So you get 4 is equal to x, and that would be your final answer. In example 3, we're going to be solving exponential equations when the base is a fraction, so it's going to be in between 0 and 1. So we have to remember our negative exponent rules, which were a to the negative m would be 1 over a to the m, And if you had a to the negative m in the denominator, you could bring that to the top. So we need to be thinking of how can we rewrite 1/2 and 4 with the same base. So take a moment to think about that. Okay, so hopefully you're thinking along the lines of 2's. So we can rewrite 1/2 and 4 with a base of 2. So you're probably wondering, how would I do that when there's a fraction? So we'd have to figure out, how do we get the 1/2? So if you remember our negative exponent rule, 1/2 can be rewritten as 2 to the negative 1 power. Then you can rewrite that 4 as 2 to the 2nd power. Then we can apply the power of power. So this one's pretty simple because when you multiply the exponents, you're just going to get 2 to the negative x is equal to 2 squared, so keeping our bases at 2. Then we're going to equate the exponents. Which means you're going to have negative x equal to 2. And then you need to solve for x. So when x is negative like that, it's not technically all the way simplified. So to solve for x, you would want to divide by -1. And all that would do is make the x positive and the 2 negative, giving you your answer. So for this last example, hopefully you realize that we have a 4 as a base and then a fraction. So we're going to have to rewrite those. 4 and 64 can both be rewritten with bases of 2 and with bases of 4. So to start, I'm going to solve it by rewriting 1/64 with a base of 4. So I know that 4 cubed is equal to 64, but notice that we have a fraction. So that means 4 to the -3 is how I get 1 over 4 cubed, which is going to equal 1 over 64. So I'm going to have 4 to the x plus 1 on the left, and then 1 over 64, that's going to be equal to 4 to the -3. So there's really no power of power property here. So the only thing we're going to do is equate the exponents, which means set them equal to each other. So you have x plus 1 is equal to -3. And then to solve for x, you would want to subtract 1 from each side of the equation. And be careful, -3 minus 1 is not -2. It is -4. All right, now I want to show you guys how you can solve this same problem, but using a base of 2. So I know that 2 squared is going to give me 4. And then I know that 2 to the 6th power is 64, but if I want it in a fraction, that means I'm going to need 2 to the -6th power, which would give me 1 over 2 to the 6th power, which is 1 over 64. So that means that the right side for my fraction is going to be 2 to the -6th power. So here you would have to multiply your exponents. So you'd have to do 2 times x plus 1 on the left-hand side. And then on the right-hand side, you would just leave it as -6. And now you can equate the exponents, but make sure you apply the distributive property on the left. So 2x plus 2 is equal to negative 6. Then you would subtract 2 from each side, and you would get 2x is equal to negative 8. And then lastly, you can divide by 2, and you get your answer, x is equal to negative 4. So you can see we got the same answer, but it just took a little bit longer. So I don't know if you guys saw it on the board, but there is a mistake on number 13 on your homework. So you can't solve this problem when it has 1/2 and 1/25. So that 1/2 is supposed to be 1/5. So the problem should read 1/5 to the x is equal to 125. Because if it were 1/2, that means you would have to have an exponent or a base of 2 to the negative 1 times x is equal to 125. And there's no way that you can get 125 with a base of 2. So definitely a typo.